We're going to introduce oxidation reduction reactions, which we also call redox reactions. The RED in redox comes from reduction. The OX in redox comes from oxidation. So here we have a typical oxidation reduction reaction where zinc solid is giving electrons away. 2 electrons are transferred from an atom of neutral zinc to an ion of copper 2. That will cause zinc to become zinc plus 2 ion because it loses 2 electrons, and copper will gain 2 electrons and become copper solid. So zinc is said to be oxidized. Oxidation is the loss of electrons. The oxidation number will go up, right? So it goes from 0 in this case to plus 2. We'll talk more about that. Copper plus 2 forms copper solid. This is reduction. Reduction is the gain of electrons. The oxidation number goes down or is reduced. And so that's how I remember which one is oxidation and which one is reduction. Reduction, the oxidation number goes down or is reduced, and the other one is oxidation. A lot of people have different ways of remembering which one is which. There are mnemonics. Leo the lion says grr. Leo is loss of electrons is oxidation, Leo. And then Leo the lion says GER. GER is GER. Gain of electrons is reduction. There's also a popular one called oil rig. Oil rigs. Oil stands for oxidation is loss. And rig, R-I-G, reduction is gain. So however you want to remember it, you do need to remember that oxidation is the loss of electrons and reduction is the gain of electrons. Now it's kind of important that you understand that in oxidation reduction reaction, the full reaction involves a transfer of electrons. And so you cannot have an oxidation, which would be a loss of electrons, without having a corresponding reduction. Those electrons have to go somewhere. So if something's being oxidized, something else has to be reduced, and vice versa. So that's what this is saying at the bottom. Oxidation and reduction go together. One atom gives its electrons to another atom. So in this case, at the top, 2 electrons are transferred from zinc to copper 2. Now these are some examples of redox reactions. We have silver ion solution on the left, and we have a piece of copper that we stick into that solution. What's going to happen is the silver ion is going to take an electron from the copper, and then another silver ion is going to come in and take another electron from the copper, and that's going to form copper plus 2 ion, and then you're going to form silver solid. So the evidence of an oxidation reduction reaction in this case would be the solution turns blue. The blue color is the result of copper 2 ion forming, and then you also see some solid silvery metal appear, and that is elemental silver. So silver plus, you stick a solid copper inside, it's not showing you that, and then copper 2 ion forms, it is blue, and you see the solid silver form at the bottom. That piece of copper that you stick in there will also get smaller and smaller because it will be converted into copper 2. Now if we look at another redox reaction, we have bromide ion on the left forming bromine on the right, molecular bromine. And then the chlorine that we bubble in is going to be reduced to chloride ion. In this case, the sodium, I'm ignoring it and as I'm talking about it because sodium ion in this case is merely a spectator ion. It's not participating in the redox reaction. So bromine forms, and that's indicated by the reddish color. Now in this case we have copper ion, which is the blue solution on the left, and you add metallic zinc, the solid piece of metal. Over time what happens is the solution becomes colorless, and that is because the copper 2 ion, which is blue, ends up taking electrons away from the metallic zinc, and that forms copper metal. So you can see little chunks of metal at the bottom. And then the copper 2 solution is converted into copper solid, but the zinc solid is converted into zinc ion. Zinc ion is colorless. So here we have solid zinc, and we have copper 2 ion, and on the right hand side we form zinc ion, which is colorless, and we have solid copper in the bottom. Now last but not least we have sodium, and we're going to heat that in the presence of sulfur. These are the 2 elemental forms. Sodium is going to give its electron to sulfur, and then another sodium ion is going to give another electron to sulfur, so that elemental sulfur can turn into sulfide ion, S2-. So the formation of sodium sulfide, this is an extremely exothermic reaction, as are most reactions that involve active metals like sodium reacting with other elemental nonmetals like sulfur or chlorine. Now if we put our molecule glasses on, we're going to put them on, we're going to look inside these flasks or these beakers. So now if we look inside, if we on the left, right, we have zinc atoms. Those are the silvery colored atoms. Those are going to give electrons away to the copper 2 ion, and that's going to form a copper atom, which you see on the right as sort of the copper colored. That's not a coincidence, the copper colored atom. And then of course we form a zinc 2 ion that floats around in the solution. That's why the solution becomes colorless, because the zinc 2 ion replaces the copper 2 ion, and zinc is colorless, whereas copper 2 is blue. Now here's another one. We're going to put our molecule glasses on over this one as well. On the left-hand side we have iron, that's the nail. Iron is going to give its electrons to copper 2 ion, which is why the copper 2 becomes, the solution color becomes less blue. And you form copper atoms which attach to the nail. And then iron 2 floats around, and iron 2 is not the same color, it's not blue, and so the color diminishes. One more time, here we have copper in silver case. We have a metallic copper, which is going to give electrons away to silver ion. So the silver ion is colorless, and then the solution turns bluer because as the silver ion takes electrons away from the copper atoms, the copper turns into copper plus 2, which is blue. So the copper solid will become smaller and smaller in mass, and it will be replaced by silver atoms. Now this is showing you that oxidation is the loss of electrons. You would go from a more negative species to a more positive species, so either A2 minus to A minus, or A minus to neutral, or neutral to +1, or +1 to +2. So the reactants might be an anion or a cation or a neutral atom. Reduction would be the corresponding opposite reaction, right? So reduction of A2 plus would form A plus.